Welcome to the 5 a.m. show. Alright, let's do this shit. Okay, where did I put... So if the ith character is O from every I2 through 16, length 16, okay. One to 16, so then it's 1. Pretty simple, but I don't want to take the 5-minute penalty. So we just make sure here. Okay. Most likely that is correct. Phi is not J. Okay, so we're giving a ranking of tournament match. Let's see here. So for A in range, we go up to n minus 1, and for B in range, A plus 1 to n. This way we're not taking duplicate matches, although it doesn't actually matter too much here. X would mean the J1. So in this case, we would put B. So then B, when count B plus equals 1, else A plus equals 1. Append. Then we need to just process the number of wins we got. So we'll put the index second, and then number of wins for index C. Okay, so if they have the same number of wins, a smaller player ranks higher. So this way they'll put the lowest number of wins and the lowest index according to this. But then if you have a higher index, you end up having a lower index in this scenario. So that at the very end there will be highest wins with lowest index. So then we do br.sort, br.reverse, and then we'll do an answer list. And this br d1. Okay, I did a out of range stuff here. Yeah, this should be an array. So we get 3, 2, 1. And then 4, 7, 3, 1, 5, 2, 6. Okay, we'll just start recording what C is. So World Tour Finals, there's M problems, there are multiples of 100 between 500, 2500. Which problems has each person solved? The total score of player I is calculated as the sum of the problems they've solved plus a bonus score of I points. Okay, the bonus score is there as a tiebreaker, I assume. How many problems must each player I? So for every contestant, we have to figure out how many problems they need to solve to take the lead. So at most you have to solve all problems remaining. Okay, let's check if B is correct. Okay, B is correct. I feel like I'm going really slow. Okay, I mean we can adjust around this. Then calculate the score. Okay, so let's just do a quick find. Okay, O is solved, and we have here. So that gets sorry that, and we have to just get the score from CRJ. So that's our current score, our highest score. BRJ. BRJ is our input string. AR is our score array. So sort max, greater than high. We can, due to the problem setup, okay, we could have, okay, well, we could have ties. Maybe, no, actually. Okay, wait. If we're already at the highest, just return 0. And then if it works, then we just star ends. And then I see the outputs all on single lines. Also, we have 111 going on here, so. Oh, I did some weird stuff there. Okay, no 1-1. This one should have 4-1. And then seven, 6, 5, 4, 0. Okay. And then we can submit and pray this works. Okay, good. Shouldn't be too screwed time-wise, I think. Okay, merge slime should be the harder problem here. This is where based on the point scaling, this should be a bit trickier. Okay, so end slimes occur 2 slimes of the same size. Okay, and we have to figure out the optimal grouping. So there's CI slimes of size SI. So in the first case we have 3 of size 3, 1 of size 5, 1 of size 6. Okay, what I do know is if there's like a factor of like, if there's a non-factor of 2 that's in one of them that isn't in the other one, then you can never merge those together, since you can only do same size. So you may as well just start at 1, push it to 2, and then push onwards. Yeah, we can just greedily go lowest to highest, I think. So maybe use a let me just make sure this is heap push, heap item, okay. For item range read ends, and then let's just put in the size that we want, and we're going to use a dictionary to keep track of how many of each one do we have. For while when D is not 0, or no wait, ARs are a heap. So that's just how many we have of that size. Answer plus equals y mod 2. Since we just agree we make as many as we can. If 2 times if this does not exist, then we need to add this into the heap. At most each one takes log n, so I think this should be fine. Yeah, all this only applies if y isn't 1. If it's 1, forget all this. Y over 2. Is it y over 2? I think it is y over 2. Yeah, and then just put an answer. It's probably something like here. Let's just see how this goes. We get 3. Yeah, the first column B and C were definitely more implementation heavy. This one is a bit less of a implementation mess, and it's more like greedy based. I'm assuming it's greedy based. Like, I think it's some sort of... Okay, yeah, there we go. If it gets past the first few cases, it's probably getting past everything else. So E, we get 450 point question, 2742. Okay, so we have N songs, random play, choose one. Once the song ends, the next one starts immediately. You can choose the same one consecutively. Find the probability something's being played after time 0, mod all of this. We have very small. We have a very small constraint. Okay, all values will be integers. Okay, there's a few things we notice. Our T constraint is quite small. Our N is quite... all of these are quite small values. So probability at time 0 is just going to be 1 in N. If we go at 1 in N there, Then what happens at the next time? At the next time at 1, we either look back, if we so let's say we had, okay, let me see here. Okay, what I'm thinking first is we use the sample input and we see where we go with this. So we have 0, 1, 2, 3, 4, 5, 6. Probability here is obviously 1/3. At time 1, all 3 songs are still playing, so 1/3, 1/3. Okay, 3 is where things start getting interesting. 3, if we're on 5 and 6, then we can't do it. Because they'll be playing up until 5 or 6 here. So we need to hit that 1/3 probability first. And then we have to hit another 1/3. So 1/9. At time 4, 5 and 6 are still going. We'd have to hit the 1/9. Pretty much we can, do we just look back at 1, or like the issue here is that if we subtract 3, we look back at 1, it has the same probability. Maybe we look just 1 unit backwards. Wait a second, I think I know what could be done actually. 0, 1. Let's place the times at the top here. So what we can actually do is we start everything at the beginning. At the beginning we have 0. We have a probability of 1 of going to reach 1. So we can put that as like a 1 for starting 0, 0, 0, 0. Then we just play a song from each one. So we'd have to make the step move. So 1/3, 1/3, and 1/3. Then from there we can take each value and push it forward some amount. Wait a second. I mean, we can have the same amount, that's the problem. Different songs can have the same length. I mean, this is all right for just figuring out the probability first. So if we're on 1/6, then all three of those push out, but only one is actually correct. So we just add 1/9 to our calculation, add 1/9 to our calculation here. And as for the other one, we get 1/9 here since the other two push outside. So then we do 127, that's how you get 727. Okay, now we need a better way of calculating this than doing each one like here. Mainly since we can have duplicates, and I'm pretty sure if you have like a 1, 2, 3, 4, 5, 6, 7, 8, 9 setup, you're just going to actually, does that work? 10,000, 10,000, 10,000. I mean, it's pretty much 10,000 by 10,000, and then you do that 10,000 times. Like, that feels like n cubed. Yeah, I don't think n cubed is going to be possible. Maybe we track the probabilities of landing on each one. So like 1, you have a probability there. You have 1/3 chance of landing on 3, 1/3 chance of landing on 5, and then 1/3, 1/3, and 6. So that's 4, 9. Yeah, I feel like there has to be some sort of double count that's occurring here. Because this is probably taking the chances that you can... I mean, we can try it out first. I'm not too confident that finding some probabilities and then just taking the last few is the answer, but we can try. Zero times x plus 1 fill probability. Our mod value is 99824433. And then if it's greater than or equal to whatever our song length is, then y plus equals whatever our previous probability is. And this will just be pow n to the m minus 2m for modulo inverse. And then probability of reaching I is y. And then for however many in the last bit, so for j in range, their answer plus equals yeah, we cannot forget at the end, we have to still divide, we have to modulo divide by m. Well, it does work for the first input. Yeah, now this is where I'm really unsure. If it works for this, then I mean, we probably have something going on. You know what, if it works on the sample input, maybe it works on the actual solution. Like, I feel like the probability... Okay, where am I getting runtime error? Oh, it is running through all the cases. Okay, so only 3 of them are runtime error. Okay, I want to try something. Choose one song with equal probability, play it to the end. We can have a constraint. Okay, I'm actually not sure where the runtime error occurs. Okay, what is going on actually here? We're having a runtime error. I mean, almost every single one is correct. I don't know, I don't like what this is doing. But then okay, did this just work by pure luck? Okay, I think I know what might be going on here. Yeah, there we go. This is an x plus 1, I think. Okay, let me... Okay, sample 1 pass. Sample 2 pass. And sample 3 pass. Okay, resubmit. In the meantime... Okay, there we go. It's accepted. Very good. Now, this gives us 50 minutes to attempt F. Somehow I've actually dropped rank from... Oh my goodness, why are you all so fast? Okay, so we're on a coordinate point, and we have to go to the cargo, move the cargo, Or wait a second. Okay, so if the cargo is there, then you move. So you can move the cargo to the right, move it up, move it down, move it left. Wait, why is this 525 points? No, wait, actually, why is this 525 points? If it's there, move to x plus 2. Find the minimum number of actions. I mean, you just have to find the distance between the horizontal and vertical distances between the cargo and destination point. And then just figure out the optimal set of moves to go about doing so. And you're on the practically infinite coordinate plane. What the? I mean, and then you just don't want to alternate. How is this E? Or how is this F? This is an F problem now? Wait, seriously? No, this isn't F, right? This is too easy for F. Either that or I'm missing something so obvious that... Okay, I'm either about to completely take the piss or this is actually that easy. Okay. If it's already in the correct position, then just return 0. D is less than F. Then we have to push upwards, else it's a push downwards. So then we have to calculate distance from. So answer is F minus D. That's just the number of vertical spots we have to do. And then answer plus equals horizontal and we have to start underneath the box. Otherwise, we just do a similar case. Except instead here we do D plus 1. Now, if B is F, C is less than E. If our C is less than E, we push into the right. Wait a second here. If we are pushing upwards, yeah, the horizontal distance doesn't change. If we're pushing horizontally, yeah, we still need to traverse the same number of vertical blocks, except now we do except now we have to go one to the left of our starting position, so that's C minus 1. Okay, then we get two cases where we have horizontal to vertical and vertical to horizontal. Okay, we'll do two sets. Horizontal distance is E minus C. Vertical distance is F minus D. So if it's a positive horizontal, we go this way, and vertical, we go this way. So if this, then we either go like we can map this as our starting point. Then we'd have to go one before here, here, into here. Yeah, we can just do a few. So A to B, then C, comma D, with C being -1. Then horizontal is E. D -1, since we're going well. And then upwards is E to F, subtract 1, since we're pushing up. BR equals still start at the same point, except if we go vertical first, we have to do C, D -1. Push until, okay, so push until we're at our end vertical point, C -1, E -1 to F. If only horizontal was positive, then we have some different lines occurring. So then horizontal, vertical, so if our horizontal line is positive, but then vertical line is negative, let's see, horizontal to, we'd have to go A, B, C -1, D, same D level. C, pushes it to E, its finishing point, and then these are +1s. Now if here you push it to F, go to C -1, E -1. If only vertical is positive, then if we start from horizontal, C +1, D -1, F -1, and then these just change to +1, +1. C is here, so C, D -1 up here, D, C +1 to E +1. Otherwise I'm assuming everything is just +1s. And then we just do simple distance case. Okay, now we see if so it really is just very careful. Is this really just careful, like just being careful with how many different ways you can do it? No, this feels too easy for F. Okay, I have wrong answer somewhere. This is one of those problems, isn't it? Okay, do all of these make sense? So the cargo will act, so technically this statement is impossible. I mean, removing it's not going to change anything. Can more or less assume the coordinate point is infinite. Yeah, there's no reason to be moving the box horizontally if it's only a vertical move. And there is absolutely no reason for you to move the box further from the goal. Yeah, I think it has to be something with the box. If your path is somehow if the fastest path is somehow in the way of the box, then you might have to move around it to +2. That's what's probably happened. So if A is C and A is greater than C, or no, wait, we want vertical distance. So B is greater than D. That will put us above our box and we need to move up. Then we have to go around its answer +2. If we're pushing it to the right, again, if A is greater than C, then that would mean we're to the right on the same level. That means we have to move around the box. It is at this point that I've also noticed that I'm not even returning. Okay, these should be a return. These need return statements, don't they? Yeah, that might have a bit of a problem. Okay, and then if they're on different. Oh frick, we have to think about this +2 increment as well here, don't we? Okay, well, shit. Yeah, this is why this is an F, isn't it? This is the troll problem. Okay, let's bring out that diagram just for a reference point here. So if your vertical position is the same, and if you're trying to move to the right, but you're already to the right, then now what about vertical? If A is C and the good part is all of these are horizontal and vertical, so most of these variables should be pretty much equal. If only horizontal is positive, then doing the horizontal move first, you have to do a plus 2 if A is greater than C. Otherwise, if your box position's higher than you're doing, you don't need to plus 2 after that. Otherwise, we get this plus 2 sense going on. Yeah, that's probably what's happened, isn't it? At least I hope it's that. At the very least, I want to see more correct responses. This actually gives you a lot more information. 47. There we go. That's an F clear. Not bad indeed. Okay. We don't have much time for G. And G will probably be a little bit out of a range, but we can give it a shot. Let's give G a shot. We have a permutation. Okay, so we get a permutation 1 to n. For every k, find the number of trees with n vertices. With the pairs of vertices okay, so we take each pair of vertices ui vi. So and there's up to n minus 1 of these such pairs. Exactly k pairs are satisfying p ui p vi. So then in the okay, so this always fail. So we're always getting 0 in the general permutation 1, 2, 3, 4, 5 to n. Okay, so our two trees are 1, 2, 3. This also brings into 3, 2, 1. 1, 3, 2. And 2, 1, 3. Pretty much 3 different cases for what's in the middle. So for k equals 0, we don't have any such inversion. Pretty much we want to look for these cases where the node index is lower, but then the value is higher. In this case, there is literally only one possible inversion. And it's only up to 500. That's another thing we need to take into consideration. Okay, rename G. Sample input 2, however, is and it's modulo 998244353. Okay, so we have Cayley's formula, which is n to the n minus 2 is the number of n node label trees. It does line up with here, since we do have 10 to the 8. Okay, now what exactly is our idea here? I mean, let me just think about this here. We have and we have a 4-second time limit. If we do n to the 4, that's too long. But n to the 3. Based on that logic, it feels like there should be some. It feels like the answer could be like an n cubed. Oh, you can't look at other people's solutions for that intel? Okay, that's interesting. Like, are you actually serious that I'm at barely cracking top 1000? Seriously? What in the frick is this problem? I don't. Okay, wait. It does say inversion of tree. I mean, it does have something to do with permutation inversions. Okay, maybe we have like under 8 minutes. It's looking a little bit. Yeah, I don't know how good my chances are with this little time left, but we may as well try. 1, 2, 3. Okay, let's try with every single. Let's try every single permutation. I mean, trivially with 2. One, 2 is just going to do 1. O and 2, 1 does O, 1. There's only one possible case there. One, 2, 3, no matter what we do, is going to be nils. So it'll just be 3, 0, 0. 1, 3, 2, we already figured out as 1, 2, 0. 2, 1, 3, 2, 3. So that's 1, 2, 1, 1, 3, 2, okay, now what about 2, 3, 1? 2, 3, 1, 2 to 1. So any of them with the 1, 3 setup. 2, or any of them with the 2, 3 setup. So this one's 2, 2, 1, 2, 3, 1. So that's a 1. 2, 3, 1. 1, 1. 2, 3. No, 2, 3, 1. That's a double setup. So it's 1, 2, 0 here. 3, 1, 2. So that's 2. 3, 1, 2, 3. 1, 2. So 0, 2, 1 again. And then this 3, 2, 1 just going to be 3, 2, 1, 3, 2, 1. 1, 3, 2, 1. Yeah, then it's just 0, 0, 3. Yeah, given the remaining time, it's very unlikely I'm getting this last problem. But what I can say is, given more time, what I'd probably do is is like you can first make an n by n table, and then if two values have an inversion given the permutation, then you just invert those. And then it's a matter of being able to do the edges. Yeah, now that I'm thinking of it, the Hamming code might be useful. Or no, it's Hamming tree. So not Hamming distance. What is it called? I sort of remember what this is. It's the proofer code. Yeah, it's maybe there's some sort of proofer sequence. Let me see. How does this work? You take the leaf with the smallest label and then you place in with the proofer code, you can just do any sequence up to n with n minus 2 total values from 1 to n. Like, you can do any sequence of that. It's a little bit complicated. Maybe I'll figure it out at some point. If I do, I probably place out a video for it. Even still, this is pretty solid. I think A to F's pretty good. Last time I only got up to E. This contest F problem is definitely easier, but it's still a good result overall. Oh, this was pretty fun. I will probably do this. Will I do this again? Probably. Even though it's at 5 a.m. Okay, let's be real. I'm probably doing this again.